Hello everyone. Welcome to Krhom Shop Live, which I kind of renamed it the other day. But we're still doing repairs. We're still kind of starting to understand what we're doing, but still plenty of fumbling around and messing stuff up and blowing components across the mat. Hopefully everybody is doing well. Do I have any update to give you from last week? I think we were looking at an ESC with like weird behaviors when I swapped the FETs, or was it Tuesday? I can't remember. Thursday. Can't remember. There was one ESC I fixed. I wasn't super happy because not everything was spinning at the same speeds, kind of, after I swapped a bunch of FETs. It was still fairly close in same ballpark of RPM. So something I did, and I'll probably have a reason to show you at some point, but I found a way to test if the FETs work correctly. So you can test whether a FET, a MOSFET, is shorted by doing continuity check, but try seeing if the FET works when its gate is pulled high to open it is kind of harder. But I came up with a solution where I use both my multimeter and power supply to put 5 volts on the gate and read continuity on the source and drain, which are like the basically continuity between source and drain means the FET is open. And hopefully I'll get a chance to show you all how it works at some point next time we get an ESC with a slow motor. And doing that should let me figure out which FET is a problem very easily and very quickly, so I can save time swapping stuff. I don't have to swap everything. It will also allow me possibly a way to test the FET on the bench if I have just like the chip and I want to see if it works. So that's going to be an interesting thing to show you all at some point. I'm quite happy it went really well. So yeah, I'll show you that at some point. Hi everyone in chat. So we have Taran as always, first in chat. Good evening. Pab, we have Danza, and a bunch of regulars now. Sol Invictus, I think I've seen you a few times. Adrien M or Adrian, I don't know if you're French or not, but welcome. So on the menu today, I did put it in the announcement. Hey, Mini Madness, I did put it in the announcement. If you didn't see it, I have this flight controller that a friend gave to me. It's actually working, but so he actually gave it to me, and he grabbed another one from my box in exchange, so he can use it in his build. And as you can see here, it's missing if you can see it here, missing a USB port, and he was having difficulties setting it up, and I don't think he had the Wi-Fi port correctly set up. So maybe I'll show you how to get the Bluetooth, set up so you can actually configure it even if you don't have a USB port, because this has a small Bluetooth chip that lets you configure the flight controller from your phone or your PC. So I'm going to start by fixing that USB port. So it's not something I haven't done before, but if I can find a donor, that shouldn't be too hard. I'm going to put some leaded solder on the pads, have a look at whether the pads are ripped out. If they are, it's going to be a more interesting fix, because I'm going to have to like rewire the traces, but otherwise it should be as easy as putting some leaded solder, putting a port on it, and then heating it up. Try to not melt the port, and hopefully I have donors that are surface mount. So first we're going to have a look under the microscope, clean it up, and see if we have some ripped pads. Let's go. That's spoilers for later. Let's go. Okay. So I see a pad that's kind of ripped out. Let me put it in focus for you guys. I need to focus it for me first. Yeah, so here I can see, maybe you can see it better under some. I think it's all fine except that one pad that's kind of ripped out. Let me grab some fine tweezers. Yeah, so it's kind of broken here. So I feel like we can just possibly either glue it back down and then kind of reinforce that joint by grinding it a bit and blobbing some solder, or we could probably just remove it and install a new pad. I think we're going to do that because I'm not super happy with how bad it's holding. We might not even do a pad. We might just run a wire from the port directly to the trace. Might do that. Let's clean everything else and see how it goes. Do I have the tip is somewhat appropriate, so it should work fine. I'm gonna add a bit of leaded, and then I'm gonna wick it all up. The leaded should help the wicking process. That's not really the most suited tip, but it will do for now. I'm just going to try to not damage the components on the side and kill them with my stuff, with my iron. But in the meantime, that's probably going to do just fine. Some tweezers, grabbing some wick. I'm going to use a better tip, a more appropriate tip. I just want my big chisel. Where's my big chisel? Did I lose my big chisel when stuff went out the back of my... Do I have my big chisel somewhere? That's my big chisel. I need to get a medium chisel at some point, because it would be more convenient, but this will do just fine. So we'll try to not put too much heat in the pad so we don't rip any of them more than it already is. There's some solder here. Let's see if you can remove just that. There we go. Let's clean it up with a IPA and one of my cubes. The nice foam cubes I really like. Come on, there's some grime here. I want to remove grime from the pad. Let's see if I can scrape it away. So now the mission is going to be to find a port that's that type. So something that is interesting I wanted to bring up is, as you can see here, the USB plug is completely surface mount, and I'm going to grab from the donor box, should be able to find what, in my opinion, is how they should be designed. Let's see if I don't have many flight controllers in my box, unfortunately, because I keep repairing them. Maybe I'll grab one from the good pile. I'll see if I can find one from a drawer of good things, maybe from the repaired box. Yeah, there we go. So this one here has through-hole legs on the USB. And as you can see on the other side, there's some holes from which it could have more solder in them, but there's some holes that the legs of the USB connector goes through. And that's good design. It means it won't get ripped out as easily. And hi Max, hi Osmos. And yeah, and it's of the things that matter in a flight controller when you're picking it up, for me, that's more important than whether it's F4, F7, has an ICM gyro or BMI or something. Have something that's well built with good design practices, like having a through-hole USB so it doesn't get ripped off the board, is something I would value more than flashy new specs that don't matter in flight. Make it durable, and so you don't have to keep buying new ones. And then that's gonna work just fine. I'm gonna put a bunch more flux actually. I'm gonna try to tin everything cleanly. And then we'll go on the hunt for a donor. So as I said, this one with the rib pad, we're not gonna put a pad. We'll just solder the port, and then we'll add a wire. I'm guessing that's probably the 5-volt one, because it's one of the big traces, so it's either 5-volt or ground. But it's not as if it needed a ton of juice on USB anyway, so a relatively small wire will do just fine. Okay, let's go on the hunt for a port like this. Hopefully I have one. I don't have many USB balls. This one is through hole. Like even the cheapo Dake ones are through hole. Pretty good. This one has weird side legs. Let me show you the dig for components, but I'm not sure I'm gonna have one. We need USB-C. I'm pretty sure it's USB-C. This one has it has surface mount, it has side legs. Like this one has the same. That's not what we want. If we can't find better, we'll see if we can make it work and kind of glue it in place instead. But in the meantime, USB-C, this guy, through hole, the nice way. Good job, Flywoo. Yeah, we might be shit out of luck. That sucks. I really wanted to repair this. Maybe we'll try butcher one of the big ones. I think we can make those work. The sideway ones. I think we can make those work. So yeah, we'll try that, and we'll find a way to solder the ground pads. So let's go under the microscope and see if the pins will match at least, because let's put them in front of each other. Yeah, it has two big pads and then what is it, 8 small pads. Looks like it will do fine. And the question, we might have to cut some of the legs so that don't interfere with the resistors here. On that other side, we should be good. So yeah, let's see if we can make that fit. So I need to remove this. And actually, so I want to heat from the bottom. I'm actually going to use the secure board instead, because I know on this board, I know the MCU is fine, so I don't want to risk damaging it. So I'm going to remove it from the secure board. And we're going to heat from the bottom. So it's time to pull out the big vise. Where's my big vise? Here. So that's, for those who haven't seen it, that's the Hakko OmniVise clone. And I'm going to be able to pinch the board here and have it elevated so I can hit from the bottom. So I'm going to have to bump the microscope up a lot. Should be good, or maybe good. Nope, not good yet. I need to be able to see something. Okay, we are the max height of my microscope, which kind of sucks. How did I do it last time? If I zoom out, it's all right, and I can focus it for you guys. So here I'm going to be hitting from the bottom. I'm probably going to cook the switch that's next to it. There's a push switch, but I'll try to lift the port. I'm going to put some flux on it so I get a good idea of when it's hot. I should see the flux kind of spread out and bubble up. And I need to wait for it to be nice and fully melted because I don't want to rip pads. I guess I don't really care if I rip pads here. It's a donor after all, but yeah, I want to keep it clean if I can. I'll go for 400 and like 70% airflow. I should change to a larger tip, but unlike last time I've done this, it was on an ESC. This time it's on a flight controller, so it should have way less mass. So it should be okay to heat it up. So let's go. Let's start heating up from the bottom. You can see the flux already spread. Maybe we'll see the tin melt. Trying to not to push too hard, pull too hard on the chip, on the USB port. Might take a while. The reason I'm doing this, hitting from the bottom, is so that I don't run the risk of melting the plastic inside the USB port. And hopefully that's going to be the case. You can see some flux move a bit. Every time it takes forever. When I see it done online, it just goes super quick. Maybe I really do need to use a larger tip. Or I could try doing quick and simple from the top also. But let's see if I can get there. Yeah, I'll try going from above and see if I can get it done fairly quickly instead. Okay, let's see if we did damage it or not. Right, let's have a look. Okay, it's mostly intact. I think the back might be a bit melted. It's all right. It's a bit scorched, but should be all right. And when I reinstall it, I'm gonna do it with lower temp and I'll do it with on a bunch of thin soldered, leaded solder tins, so it should be much better, much easier. So as a reminder, we're trying to put it back here, and obviously we know it doesn't really fit. Managed to. That's not the right tweezers, I guess. Oh, it is. So that's where we want it, and it looks like it's gonna grab just fine, actually. Yeah, it should grab just fine. Just not designed. Maybe it was designed to have those pads on the right, left and right. Just perfectly fine. They do look a bit wide for it, but hopefully it fits. So I'm gonna heat it up, and what I might actually do is first melt the solder with my hot air, and then put the port on, and then press on it and wait for it to infuse, so I don't run less risk of melting the port. I'm gonna lower my temp to 340, sounds reasonable. 40% airflow. All right, let's go 50%. And put a bunch of flux and dry it. And if I fail it, then I have another go with that other port. All right, so let's see if I can use the right tweezers. I have those tweezers, those long and flat, and I should grab the port perfectly. Yeah, it's nice. Hopefully it doesn't try to solder itself to the board, but should be okay. All right, I'm gonna move the other board, that's kind of annoying, and let's go. Small pads are already melted, the big ones aren't yet, I don't think. There we go, one melted. They're all melted. Now the bottom ones aren't, top ones. There we go, they're all melted. Ah, there we go. I think we might be good. We might need a small reflow. We will need a reflow. We'll need to retouch those. Actually, I think I'm kind of would prefer doing it with the iron now, so I don't risk melting. Let's see if it's crooked. It's fairly flat to the board, so I'll do the touch-up with the iron. Yeah, I'll go over all the pads, and that should be a better way to ensure it's all nicely covered. Put some more flux on it, and because I don't want to run the risk of melting the plastic. Is my my thing? I've been having issues with that handle. It just stops detecting my my tip. It's a bit annoying. There we go. No, got a good coverage. Good coverage. I just want for the solder. Let's put down some flux. I want the solder to come and grip the metal part. You can see it. And then go over it. There we go. Let's put. I'm getting spikes, so I'm just going to put more flux and come tame the spikes, but there you go, nice blob. Common spike. Let's clean the iron so it doesn't want to make a spike. Maybe it's not a spike, maybe it's just, yeah, it's not necessarily a spike, I don't know. Yeah, these guys are okay, it's not the prettiest job in the world. The port is still unmelted. Let's go over the pins. I'm not sure that, yeah, I'm pretty sure that none of them are connected. Actually, as you can see, the port isn't really flat, right? It's leaning to the side. So I'm going to come back with the hot air and still like heat it up so I can push it flat actually. I'm going to go up in temperature because I was having issues melting the whole thing at the same time. So I'm going to go 380 and a bit more airflow. And we're going to see if we can do that quick without melting the plastic. Melting here. There we go, now it's sat down firm. I saw it sit down firm, so should be way better here. And let's see. Okay, that's way better. That's flat. It's a bit scorched. Let's check if I put a USB cable in. Does it click nicely or not? And then we'll... Solid Invictus, you're asking what is the material of the things I used to clean. So let me show you. At the core, I'm using IPA, isopropyl alcohol. So I have it in those small bottles that you can get for super cheap off AliExpress. And they come with both a needle you can use. And that's a nice way to add IPA in precise locations. I also have this dispenser, which I fill with IPA. So yeah, iso alcohol. And you press it and just pulls some alcohol there. And that thing I will use with either those nano cleaning sponges. That's from Maant, and it's like €2 a glass plastic bottle. And those you can kind of fill with IPA on your small fountain thing, and then it cleans and sucks the flux up. It's really nice. I really like this. And otherwise, I also use Kimtech Kim wipes. They are like kind of very thin paper that doesn't leave lint and doesn't get torn apart when you clean. So maybe I'll show you how I use those when I clean up that port. But yeah, and a brush as well. So let's see if my USB still clicks. Okay, that looks decently clicky. So now I'll do a pass. Those look kind of soldered, but you never know. I'll do a quick pass with my small iron, bunch of flux, and let's put some flux in. I'll come press on them. Actually, I can remove the glare, but then I don't see anything, so I want a good perspective. Oh, it's not clamped. Let's clamp it. Okay, just pressing on the pins and melting them with the tin underneath. That should, and that's ground, so I'm never going to melt this. And this one we need to reconnect. All right, so now we do a bit of cleaning, and then we work on repairing the trace. And hopefully that works fine. Also, but it'd be nice to remove that glue. Let's see if I can remove it with IPA. We have a question from Spawny. Hey, Spawny. Dylan says, should I bring heat from the top and plug the dummy into it? I was thinking about it, but like the people I see doing it from the bottom seem to kind of do it well, but it doesn't seem to be working for me. So maybe I'll do that next time, probably. Hey, feet. Spawny asks whether we started early. Oh, we started early. I was confused because my my French streams are at 9 and okay, well, I guess I'm doing three hours today. All right, we'll have a long stream. Yeah, I usually start at 10 here, but my French streams on Thursday are at 9, and I had a very long day at work, and I got very confused, so I started early. So we did start early. But yeah, I'll probably be there for 3 hours then. That's all right. I have plenty of things to repair, never running out. So Invictus, the material for my sponge looks similar to Magic Sponge. I don't know what Magic Sponge is, so maybe. Yeah, between the stream last week where I couldn't do it on a Tuesday and I had to move it, and then this week's stream where I just start at the wrong time, well, I'll be sure to say hello to whoever joins in half an hour. I can pretend it's the start of the stream. Hey, you missed absolutely nothing besides repairing a port and a trace and everything. That's okay. I don't mind streaming for a bit longer. All right, so that trace is the big trace next to it. Should be fairly easy. Let's clean it up. So the other way I clean up, so Invictus, is I use that wipe. I put it on top, and then I use put some IPA on it. Oops. And I kind of douse it in IPA, and then I come with a brush. This is a fairly fine bristle brush that lets me kind of go into the nooks and crannies, and that way the Kim wipe picks up all the flux, and you'll see it's gonna go like yellow. And as you can see, it doesn't really tear off, like a tiny bit, but not much, and it doesn't leave a ton of lint. So it's really good stuff for, I mean, it's designed specifically for that goal, so good thing that it does it well. So you can see it's dirty, and the board is decently clean. So that's the other way to do it. I think they all have their moments, but I'm really liking the sponges. The sponges are my favorite. All right, so now it's time to pull out the grinding pen, because I did get one and I haven't used it yet. So let me show you what I got. And it was not very expensive on AliExpress. That's this thing. It's a polishing tool. I'm going to be polishing some some traces, revealing bare metal. So I just opened it once, but haven't really used it. So I'll try to. Will I successfully open it a second time? That's the question. Hey, Neo. So this thing hopefully has enough charge from the factory to do what I want, and it comes with extremely tiny tips, which is exactly what we want. Let's go for, I guess, this extremely tiny tip. Push it in, and let's see under the microscope. Why are my nails so clean? Are my legs clean? They usually, I mean, I kind of wash my hands every once in a while. So under the microscope, that might be actually too small. That'll do just fine. Let's zoom in, enhance. And Let's see if we can turn it on. We can. Let's see if we can grind. Yeah, seems to do the job just fine. Let me grab a sponge so I can clean at the same time. Sponge might not be the right tool for the job here. It kind of is still. Yeah, I think that might be just enough. Funnily enough, it feels like the thing is slowly accelerating, like it's urging me to move forward. Okay, that looks pretty good. Maybe we might just be able to bridge it. Might not need to use a wire at all. We'll just blob it. Let's use a very thin Q-tips. So that's also a fun thing I tried. Like, because I like trying stuff, I have a bunch of Q-tips and I have those tiny ones, medium ones, foam ones, which are pretty shit. I would not recommend them. They have a sharp tip, but there's pretty much no foam at the tip, so I'll try this small one. Every week new stuff, yeah, pretty much. I usually have like about between 3 and 5 AliExpress orders per week because it's so cheap. I can't stop myself. So yeah, let's see if I can bridge this thing. Let's use an appropriately sized tip, and I'm probably gonna have to clean the inside of this handle because the contacts are going bad. I should just probably just use some electronics cleaner type stuff. Let me push. I'll put back the microscope. I'll just dollop some flux, and I'll bring the solder. Let's use the smaller solder wire. Still gonna be ginormous, but so we can't see shit because of polarization. Can we see anything else here? I mean, that's... Right, let's have a look on the side. I'll put down my iron, give us some perspective. Yeah, that looks soldered well enough. Yeah, decent. Now we'll see if it works. We'll clean it up and plug it in and see if it works. And hopefully it does. Once it's cleaned, yeah, it looks like it's probably doing the job just fine. Yep. Right. If it's all repaired, I'll probably reinforce it with some UV glue on the sides. So let's go to the PC. Oh, it's still a bit grimy. Actually, let's clean it up a bit more. Just use some IPA and a clean wipe because it's all sticky. Right. Moment of truth. Actually, before the moment of truth, I might I think I need to be super careful with this and park it and very carefully every time because the tip is so tiny, you're probably very likely to break it. And I'll probably use pliers to remove it actually. because there you go. I don't want this to break. I don't have a million spares yet. So, but yeah, it's doing the job just fine. I'll put it, I'm probably not gonna put it back into its box, but I have now organized my drawer, so I know where to find stuff. That's pretty good. But let's see now whether we have fixed it or not. If we haven't, it's probably one of the pins that not working. So pull USB. And here, I think, well, first we're going to be looking for lights to work. So let me pull you in a bit. Where are the lights on this board? Probably on that face. I can't see them. Where are they? Huh, they're somewhere. Let's plug it in. Hey, lights! So at least we have 5 volts. Now we go here and we check whether we can connect, which looks like we can. Yay! So that's fixed. That's a good one. We haven't done USB port fix and a bit of trace repair as well, so easy peasy. Oh, that seemed like it disconnected a bit too quick. No, that's just when I pushed on it. Okay, we're fine. We're fine. Isn't that tool for nails the grinding pen? If you have tiny nails, maybe. Tiny nails, but otherwise probably not. So yeah, D-Line is saying, gotta buy before the new import laws. The new import laws have gone into place and has affected absolutely nothing, because now, so for those who don't know, probably there's no reason you guys would know if you're not French. The French government wanted to say no to small packages coming from China because it's not good for the environment or something. Or maybe it's a commercial thing, I don't know. So they decided to tax all small packets under 150 euros or something like that. And says, hey, if you land, you have to pay €3 per thing in that box, per object. So what happened is ships stopped landing in France. They started landing in the Netherlands or any other neighboring countries, and they shipped the last mile to us. So it just changed absolutely nothing besides probably cutting some revenue from the French airports. So yeah, didn't change anything. Yeah, Belgium, they come through Belgium as well, yeah. Bravo for politics. Very clever. So yeah, I didn't see anything change on AliExpress at all. All right, so let me finish cleaning that board. I'll put some UV resin on it as well. I'll show you how I do that if you want to see it. I mean, I'll show you anyway. You can just close your eyes if you don't want to see it. Let's zoom out. That board is disgusting. So much flux. Oh yes, I said I would show you how the whatchamacallit Bluetooth works. So I want to put some resin around this. So what I want to do is first ensure it's nice and clean. So I'm going to do some more cleaning for a bit. So there's no, because if you start putting glue on top of flux, it's just not going to work very well. Probably time to go back to the Q-tip actually. Yeah, so the Q-tips do have their place if you want to reach in places. Yeah. Okay, so it should be good. And I'm gonna actually pull back my grinding pen, and I'm gonna lightly scratch the solder mask around so that the UV glue grips well. I'm gonna try using another type of grinder tip. See how it goes. It looks funny. It's gonna be this one. And I don't want to, I just want to scratch. I don't want to go through to copper. So I need to go super light. Yeah, maybe it's when maybe I can probably go slower. Yeah, that's way slower. Yeah, I probably can't go here with that tip. Maybe we don't. I'd rather not do it very well and not kill the board rather than kill the board. I'm just going to put it on the side anyway, so let's see if I can reach inside this. There we go. Tiny bit of grip. That might be completely useless, but good conscience. I know that when you do trace repairs, using scratching the solder mask does help retention on the UV mask. And what I'm going to put is not exactly UV mask, it's UV resin, but it's very similar. So with my Q-tip, I'm going to clean that up. Yeah, probably didn't need to go up there, did I? And I mean, the UV glue is not non-conductive anyway, so even if I reach copper, it doesn't really matter. But yeah, my UV glue is a thing you can buy. I recommend you get some actually on Amazon, on AliExpress, I mean. That kind of stuff. It's super useful because it cures in seconds under UV. You can buy it with a small UV pen that works fine. It's kind of still a bit flexible when it's cured. And yeah, it lets you glue stuff instantly. It's really nice. Let's see if I can use the applicator tip and not put too much. I probably can't. I'm gonna use some pliers, some thick pliers. What pliers do I not like? Those ones. And I'm gonna grab a small piece of plastic. Find some. Yeah, there we go. Just use a small piece of plastic, put some of my glue on it, and then grab it with my tweezers. So we're doing a bit what they did on the other components on the side. Just adding some strain relief, basically. There we go. The other side will be good. Just for some strain relief. There you go, that's plenty. Now we take our USB curing lamp, put it on top of it. Oh shit, I forgot you can't use USB-C to USB-C with this lamp. You should be able to see, you can't really see it cure, but kind of, it doesn't really go opaque like some solder masks do. I'm gonna leave it there for a second while I clean up my my tweezers. Like you can clean with IPA. IPA dissolves resin. Actually, the reason I have all that IPA is because I used it for my resin printer, and resin printer resin is very similar or possibly identical to this. So might not have exactly the same curing properties, like there's plenty of different resins too, but yeah, but it's very similar. This seems to smell less, but yeah. Oh, thanks Neo for finding the tool. It is indeed the Mechanic GR2, I think. Maybe there's a yeah, GR2. That's it. All right, let's go back to the microscope. We'll check that it's cured, but it should be. You can see, nice and solid. Nice and strain relieved. And hopefully we haven't bricked it. Oh, did we break it? No, we haven't. And it still connects. And it still moves. Yeah. Okay, so that's good, that's repaired. So let's see now the Bluetooth part. So what we want to do, how long does it take to dry? I think the UV resin like that, it takes a few seconds under UV light. I tend to leave it a bit more, like 30 seconds, but it probably doesn't need that much. Some of them are faster than others, but this one is seems to be super fast. All right, so what I wanted to do, yeah, first I want to connect to it through USB. And I want to check that it has the port that the Bluetooth uses connected to MSB. And you can see it has UART6 here, connected as configuration MSP, and that's what the Bluetooth uses. So now we'll see if we can power the Bluetooth. So I'm gonna, so you know I don't cheat. I'm gonna use my power supply USB stuff to power it up. Okay, and now should be able on my PC you can do that with your phone as well. But here I should be able to say I can't find my Bluetooth device. And here, now we look for, so what I don't know is whether it, oh, it pops up on USB, but it seems like it does. T-motor S pair, and now connect. Serial port successfully opened. Yes, good, good. Can I get connection, please? Unexpected read characteristic found should be something. Okay, so I'm guessing maybe that's not the right port, so we're gonna have a look at the documentation. So that board is a T-motor Velox F7 SE. So we might have the wrong port selected for the Bluetooth. We'll see. Can we find a documentation? Do they have a proper documentation? Come on, T-Hobby, you can do it. Of course they won't say, okay, description, yeah. It sucks when they don't have a proper documentation. So we don't know what serial this is. And it came pre-configured on UART6, but might not be the right one. We could try them all, but yeah. I love it when there's no documentation. Yeah, there doesn't seem to be documentation. So we're gonna try a few different ones, maybe. Let's go over this. We can always randomly try. Why is UR2 also selected for? Oh, that's MSP DisplayPort. I guess we can try UR4. The other one, actually, I'll try that, but we can also have a look at what's not under the, what UART is not used on the board. That could be also. Yeah, same thing. Maybe the Bluetooth doesn't work on this board. That's also a possibility. Like the thing is kind of broken. That's very possible. But let's see if we can figure it out. So if it's not UART4, maybe it's UART1. Could be UART3. We'll try this. What I wanted to show you is this whole, the fact that you can connect to Bluetooth with this configurator. It works really well. It works on Android as well if you install the APK for Android Betaflow configurator. It's quite nice. Let's see. Yeah, well, I guess we'll never know. I can try the last one we haven't tried yet, but I'm very doubtful. You haven't tried UR3. Normally, you only have to put that MSP on the right port because the Bluetooth chip is wired to a UART internally. Can't really know which one besides the documentation, and if they don't give you anything in the documentation, then kind of tough luck.
I think it's either 4 or 6 because all the other ones are on the board.
Yeah.
But only those two are missing.
A 4 should be in the, I think 4 is on the DJI plug.
Yeah, not even.
No?
Yeah. Oh, no, maybe. No, it's Moto 4. I'm not sure.
Because, oh no, 4 wasn't, I tried 4. I'm pretty sure it would be 6. Maybe it's another. Oh no, MSP DisplayPort was on your 2, so yeah, I tried 4 before. Maybe it's another baud rate. We can randomly try another baud rate, but I mean, maybe it's very slow baud rate, but I very much doubt it. So I'll check that to this board having an issue. I'm not going to spend all day on it, but I've used it before and usually works quite well. Yeah, here looks like it doesn't. Maybe it only works on power, but shouldn't do because I can see it. So I don't know. Oh, well, at least now it has a USB port, so it can be configured, and that's what matters. Let's put it in the box of the things that are fixed. And move on to the next part. Oh, did I just put my arm in my... No. I thought I just put my arm in my my resin pool thing, but I didn't. That's good. Well, actually, you wanted to see how long it takes to cure. Let's do a trial by using... Let me grab the lamp again. And what I'm going to do, I'll put this into the microscope, and I'll stir it while curing it. And we'll see how quickly it goes. We'll have to kind of use, let's go maximum glare, and focus on it. And we'll use try the best judgment on trying to understand whether it's cured or not. Well, I'm going to stir it. I have my light here, and so I'm going to stir it like this. Oh yeah, oh yeah, oh yeah. It takes a few seconds, as you can see. That's already hard, and that's not hard. Yeah. So yeah, you can see. Oh, I've glued my tweezers. So yeah, you can see it is really quick. So hopefully that's enlightening. See you later, Spawny. See ya, Dylan. I missed Dylan leaving, but have a good one. So yeah, super quick, and I'll show you like it's kind of still soft and flexible and pliable. You can see it's not cracking, so it's nice for strain relief. Kind of like it. Kind of like it. So yeah, good stuff. All right. Let's tidy that up. Right. So next we're going to be looking at, where did I put it? This ESC. It has recently died, or maybe not recently died, but it has died. It has some very clear sign of stuff happening to MOSFETs. So we're going to do the usual diagnosis and see if we can find some donors for it. Sorry, having some water. All right. Let's start with the meter, as always, and put that where you can see it. And the box don't need the box. So let's go. First, continuity checks. So we're looking for no beep here. We're looking for no beep to all the pads. That's to detect shorted FETs. And that's to kind of kill things that will kill a motor immediately. So when you have a shorted FET, you have a motor that fries. Oh. Yep. We have a shorted FET here. Do we not? What did I do? Was it just a capacitor charging? No. How did it go beep and then not beep? That's weird.
Maybe it's too dirty.
Yeah, but that wouldn't cause a beep unless it's like conductive carbon all across, but I wouldn't think so. Maybe it was just charging a cap, but weird. Oh, there we go. I might have it not set up correctly on the. So yeah, this FET or the other one. So yeah, so there's definitely short here, which is weird because I can't get it at all times. There we go. So we'll put it under the scope and start with removing the FET that beeps, and then we'll go and start with cleaning stuff up, as always, so we can see a bit better. Let's go Mamba. Oh, that's dirty. Sometimes I wish people gave it a good clean before they gave it to me. Yeah, we're probably not gonna do. Let's go for the big solution. Go grab some some big towel. Oh, and we'll just douse it in IPA and scrub. Given that the kind of grime that's on it, I should really be doing it with water, because water is way better at removing dirt than IPA. But then I would need to make sure it's very, very dry before I do anything else to it, which, to be honest, would be fine because I'm going to put it under hot air, most likely. So that will dry it up. But yeah. Nice and dirty. Let's go for more. For those who wonder, you can actually get drunk off IPA fumes. You just need to breathe a lot of it. And apparently it's not a very comfortable drunkenness, so would not recommend. I haven't done it, though sometimes I've sprayed IPA on my printer bed to clean it up while it was still hot and got a nose full of IPA vapor, and it was not pleasant. But I have not gotten drunk off it yet. So, probably not a good idea. There we go. Now we clean enough. We're clean enough to go under the microscope at least. There we go. Microscope time. So we can see this FET looks like it has possibly some damage. Might be the one under though. It's not really clear. This looked like damage from afar, but it's not. It's just glue. So that doesn't say anything. That cap, why not? They're just soldered to the cap next to it. It's probably fine. It's the same trace, I would assume, since it works, but it just feels not very clean, but it's not a problem at all. So you can see some corrosion. Oh shit, it's still dirty. Dirty. Let's see if we can get there with this solution. Yeah, to some extent. So it looks like some of it is really caked on. Good enough, probably. Just do it kind of. Yeah, it's old flux, kind of making it sticky. It's good enough. All right, so we think this one, let's see if it's this FET or the other one under it. You should be able to just test if it's shorted. Yeah, this one's shorted. Let's see if it's, I think it's companion under will not be. That should be this guy. Yeah, that guy's fine. So we'll definitely need to remove this guy. And then we'll double check for shorts. And then I'll do probably the thing I mentioned before. I'm going to test all FETs using my voltage injection method, so I can open all the FET gates and kind of drive the MOSFETs, because that way I get to show you how you can do that. It actually doesn't require much hardware, just a multimeter and a power supply, which, as I have to remind you, you have a power supply if you have a modern charger. They have a power supply mode most of the time. So yeah. So let's remove boy. Oh, if I hold no, there's no way I can hold the board without it hitting the pin. So what the problem I have is if I hold the board like this is going to melt as I heat up the board, and then it's going to stop clamping, so I kind of need to clean those pads, all those pads, and that way I can hold it this way. So I'm probably going to do those two. I'll just heat them up and use a solder sucker and try to suck. I have a new improved solder sucker because I always have new stuff. That's a beefy solder sucker that looks quite more durable than the plasticky, cheaper one I had before. So hopefully we can get a good result. Let me swap to a big tip. My big chisel. And we'll try sucking that solder all the way. See if we can finish it from above. Yeah, that's not too bad. That's not too bad. Oops. Not bad. Always find those kind of awful to use. But I guess it's probably just a trick, like kind of getting used to it. Because that did the job beautifully. Let's finish it up. Standing some shards of molten stuff all over because I'm not discharging it correctly. I think as I repump it, I'm supposed to kind of discharging. Oops. Yeah, good enough. I can finish with a wick. Just grab a bit of wick. As always, if you have any questions about electronics, repairs, diagnostics, how stuff works, how general FPV questions about builds, feel free to ask. Just tag me with my name in the chat. That way I see I can't miss it, but also there's not a lot of chatter in this chat at the moment, so I will definitely see what you're asking. So yeah, go ahead, feel free. There we go, all nice and clean-ish. Clean enough. And I have a mess of solder on my desk. Solder shards from the pumping. There's a bit of mess here. There we go. Now we should be able to hold the board better. I'm going to try to hold the board in a way that I don't put any pressure on the plug from below. That way it won't move even if the tin melts. I'll double check that it's this FET, but I'm pretty sure it is. Yep, and let's remove this. Actually, before I remove it, I should probably test all the other ones with my method. So my method consists of, probably should clean those, I should probably clean those pads quickly. I'll clean those pads quickly because I'm going to have to clamp on them with a what's I call it, with alligator clips. So might as well clean them up a bit. going to be, or otherwise it's going to be hard to clamp to them. And the reason I'm not using wick here is because, first of all, wick is expensive. Well, more expensive than free. And a wick, to wick that much solder, you really need to use a lot of wick. Can I just melt it on the side like this so I can, yeah, better.
I have a question about desoldering the pads like that. Is there any reason to do that? Maybe can't you just add some flux and use the current solder?
But I want them without solder because I'm going to use alligator clips on them. So I want like the contacts to be nice and clean. Also, there's satisfaction to having clean pads, I guess. But yeah, I could, if I was just going to solder motors, I would leave it that way. Okay. I would just probably just use some flux and use my, like basically doing like I'm going to show you. Where's my flux? Here's my flux. I would put some flux on and then use my iron to remove most of it, like this. And now I have a fairly nice and shiny pad. That's not just a massive ball. But here, I mean, I could just do that for all of them right now because that's shallow enough so that I can clamp my my alligator clip. So yeah, that's not a bad shout, to be honest. And that's definitely faster. I need to clean the iron tip to remove the excess solder. Because I'm kind of grabbing a lot of it with my iron. It's like, yeah, that should do the job just fine for my purposes. All right, so now what we want to do is ensure that we know which part of the MOSFET is the gate. And as I've explained it a few times, but a MOSFET has 3 actual legs, and this all 4 should be connected together to form one leg called the drain. And here you should have 3 pads for the source and 1 pad for the gate. So if we check for continuity, well, let's check on one that's not. Oh, so this one is a bit different than the one I've used before. So those 2 are continuous, but this is not. So this is the gate. So this is the source, and here are all the drains. So it should all be continuous. There you go. So opposite the circle. Oh yeah, pin 1 is here. Sorry, I thought that was pin 1, but pin 1 is here. Decided by a small circle here, and usually pin 4 is the gate. So now what we want to do is right now, if I test for continuity between drain and source, I get nothing. I don't get a beep, I get open line. But if I were to inject 5 volts here, it should start beeping. It should make the FET, turn the FET on, so make it like a switch you enable. So now what I want to do is, first of all, so this is connected to this. So what I can do is, so to open it up, I need to put 5 volts between source and gate. So if I put my black multimeter clamp here and my black power supply clamp here, I'm going to have a ground, and I can measure here for continuity and send 5 volts here. So that's what I'm going to do. And that way I only have to manipulate 2 probes, and then the other 2 are going to be on the alligator clip, which is what I want. So I'm going to show you my setup from the overhead. So on one end, my multimeter is going to be connected to my power supply ground. So that's my power supply ground. I'm going to put a banana plug here, and on the side, I'm going to pinch my multimeter. So that's now the same connected to the power supply ground. Now this is going to go on the pad I want to test. This is going to go on the drain, so I can test continuity. And now I just need to have 5 volts. And I'm going to have 5 volts. I'm going to use a very, very low amps, like the minimum my PSU can do, which is 100 milliamps, because we don't want to short anything if it's broken. And I'm going to use my PSU wire here, and I'm going to, instead of this, use a sharp pin. And now I'm going to be able to inject 5 volts with this. So I'm turning my PSU on now, and I'll show you under the scope. So now, for each of those FETs, except this one we shouldn't want to test, that's not the one I wanted. So I'm going to go and set the ground on this guy, right, which should match this guy. So here, if I probe here, should be beep, because that's continuous. And if I probe here, that's no beep, because the MOSFET is closed. Now, if I take my 5 volts, let's ensure that this FET is in the same direction as the others, actually, because I wouldn't want to start injecting voltage in the wrong place. I just want to be able to see that it's in the same direction. Pretty sure it is. The reason I'm pretty sure it is because I can see from the trace here that there's kind of a space for that pin to be something different than the other three. But I just want to make sure. If I can, please let me remove this. Yeah, I can see the circle here. Okay, we're good. We are good. So what I wanted to say is now I'm going to put my probe here, and as I inject 5 volts to the gate, it should beep if the thing works. And it does. So that's opening the FETs, basically. So this FET does. This one, we know it's shorted. We'll test the third one. Try to not short to another one. And same thing, so I'll test this and ensure the FET is working. All good. And now I need to move my ground. Let's try this. It's hard to find a good. Next. That way I know if I need to replace another one because it's failed closed, which, I mean, I don't know how much I would want to do this every time, how much time is saved versus trying it and hoping it works. So here I might have some grime on my probe, so I need to make sure I have good contact. There we go. Because it looked like it didn't work, but it was just bad contacts. So you need to always make sure. Let's try to not short. So here we have good contact. Good. Now we do the other side. And then the other face you'll see is actually much quicker because here the source is referenced to the motor pad, so I need to change my ground every time. But for the other ones, all the sources are referenced to ground, so I can just put my plug on ground and test them all very quickly. So here we want to test this guy. Let's see if I can get a good contact. This one. So is it dead or, so let's see. That's good, so that's the right pad. I'll try to remove stuff to make sure I have good contact, because it could be that I just don't have good contact on the pins. But right now it didn't go beep, so Need to see if it's dead or not, dead or alive. So I'm kind of trying to scratch the oxide layer so I can get a good contact. Okay, it looks like it's dead. Let's try here. Interesting. So this guy is dead. Yeah. We'll see if we can mark it as dead, so we don't forget. Well, so hopefully remember that means dead. Let's keep going. So that's the one opposite the one that broke. I mean, it could be that it's backwards. But no, it shouldn't be. It should be the symmetrical of the other one. Yeah, it's the right way around. So it's dead. Sorry. This one. Oh, it's so spark. But so that's nice and continuous. You can see a spark, which is fine, which isn't necessarily bad, but I think the other ones aren't doing a spark, so this one might be dead as well, which would make sense for being opposite the. Oh, that's not opposite the one that died. That's the one. That's the one opposite the one that died. So yeah, this looks pretty dead to me. Okay, and the spark probably it kind of confirms it. We'll mark it and go to the next. It's hard to mark those things. Can I mark them any other way? I could use my grinding pen. Probably should leave that with a bit on it if I'm going to be using it all the time. We have a question from Pab. Do I need to make a bomb of all the stuff I get? Of my new stuff I thought, oh, that would be a lot to track down. At some point, I'll take the time to write what the stuff I use. But for like all the stuff I order, if you see something that I haven't, that you want to know, I can give you the reference, but I'm too lazy otherwise. This guy, let's try this guy. Good. Good. So yeah, this might prove to be a very good way to diagnose dead FETs. I'm quite happy with it. Good. I mean, it makes sense, right? There are switches, turn them on and off, and then you'll know if they work. Yeah, and I'm not getting a spark, so they're probably not destroyed, not destructed. So for the other side, for all the other ones, I should only have to ground because they're the low side MOSFETs, I can just put this on ground, and now I don't have to move anything. I can just test them one after the other. Just need to make sure. So the gate is pin 4, and I want to inject voltage on the gate. So gate is this guy. And here I can make sure that those are all continuous to ground. So gate is this one. So in this case, I just test this. Good. 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 Let's swap my hands for the other side. Kind of had to be a bit ambidextrous for that stuff. Pin 4 is here. Beep. Good. Not good. Good. Yeah. Look like this. Oh, it's not dead. Maybe I need to check the other ones I marked as dead. Maybe they're not dead. Oh, yeah, that's the shorted one, so obviously it's continuous here. So it should be. If I can get good contact, I should get continuity. Yeah. So let me mark this guy. I'll double check the other ones just. And lastly, this guy. Let's test here. Oh, this guy is shorted too. I didn't notice this. So this should be shorted. Yeah, it is. Okay, so this guy is dead too. There we go. Good thing we checked. And that explains why the... let's check if it's their colleagues that are dead on the other side. Yeah, it is. So that explains it. Some of them shorted in one side and the other one broke on the other. So I need more 4 FETs for this guy. And they're all marked. So now it's only a matter of finding a donor, which I hope I have. We could just find something similar to, and it will work, most likely, as long as they don't have a similar pinout. But yeah. I'm not sure which one you mean, Neo, but I think I'm pretty clear now what's broken. It makes complete sense. So those. Do we have a Mamba in the donors? I don't know if we do. So if we don't have a Mamba, we're looking for, I don't know what that logo is. If someone is an expert in chat and you know what that logo is, kind of a S with kind of a thing crossing over it, or is it, yeah, I don't know. I will see if we have some of that. Let's see. These guys. That's alpha and omega. That one I know. Oh, this could be. It's a different kind of brand. Okay. So not. It probably works, and we might try. If I can't find a donor, I'm going to try random FETs and see if it works. The Goku FETs, they're burnt, but I have a bunch of them in the box. There. It could be. It's hard to say. Different brand. This guy. This guy is different, and there are shorter FETs as well. Not exactly the same size. Is it? No, it's not the same kind of bolt. What do we have here? Oh, it looks like this. No, it looks like the same as the one before. There's so many FETs. What's written on those ones? Can we see in some way? Nothing too similar. What about the SpeedyBee? Are they using? They're still using the same kind of symbol we just saw. I feel like they're probably good enough. That's probably what I'm going to use if I can't find a proper match. Those are the smaller ones. And another kind of triangle with a triangle in it. I don't know what it is. What do we have still? I think we are. Those are different. Yeah, I think I'm just going to go with some of the SpeedyBee ones because I have some of them pulled already in a box. So I'm just going to try that and see how it goes. Sounds reasonable enough. We'll just check that they have the same pinout. So let me grab that box of SpeedyBee FETs. SpeedyBee FET. And we have a bunch of them. I did desolder a ton. And they should have... Yeah, if we consider... Let me grab one. If we consider that pin 1 is opposite the circle again, I should be able to check. See that? Yeah, it's going to be... The gate is going to be the same location, so that will do just fine. We'll try that and see how it goes. I mean, that's a FET is a FET, isn't it? So now we take it to the heat. So what I'm going to do is do this face first, remove and put the new ones. And then the other side, remove, put the new ones. We go full blast. So that's going to be like 450, 460, full airflow. We lower the airflow later after to put them back. I will use a bit of flux to clean up the pads, might as well. But I will be putting a bunch more very, very soon. Okay, let's go. Hopefully this is just a very straightforward repair. Could be for once. I will try to not burn myself. And you know the drill, after we remove the first one, the second one is very easy to remove because the board is getting quite hot. Trying to angle the hot air in a way that it doesn't bounce to my left hand and burn me. It's a bit... Come on, you're very close to coming off. Sometimes they just struggle to come off. Yeah, so I need to pull it a bit harder. We might have damage to the PCB underneath. That might be why it's struggling to come off. There we go. Maybe not. Maybe it was just the glue, the stupid glue they put on. Okay, let's do those. Let's not do them at the same time, the SpeedyBee ones. So that's... Because I know last time I tried to rush this, kind of ended up messing it up. So, actually, let me put on some leaded, a bit of leaded. Doesn't hurt anyone. There we go, should help. And let's do the other one as well. Flux. go. And we're gonna come with my right angle tweezers. Where are they? Where did I put them? How do I manage to lose something that easily? There we go. So that's the right direction. Yeah, let's go. I'll reduce the airflow a bit. I'll go for like 60%. Still keep the turbo hot temperature, try to go in and out quickly. Yeah, should be good. Let me grab another one. Add some flux here. Grab another one. Here, so it needs to be turned. Tweezers. I love it when the solder balls fly away. There we go. I think this one's good. Let's do the other side while it's hot. I'll try to not damage the plug. Try to go quick. I'll start with this guy, and the heat will make me remove this one faster. And try to angle the heat in such a way that it doesn't hit the plug. I'll try to do this. Not the right way to do this, but I'm going to do it anyway. There we go. There was no damage through the board. Oh, should have done it this way. Okay, so now a little bit of leaded. Flux first. Flux. Flux. Don't want to put on too much so we don't squeeze gigaballs, but should be enough. And the flux seems to be in good enough shape, so let's put on some more SpeedyBee FETs. I wonder if we're going to have a big discrepancy in speed of the, or maybe we're going to get some smoke because the specs of the FET, like there's something called dead time, which is the time you need to wait when you close the FET before you open the next one so it doesn't short the battery completely and smoke stuff. And maybe those are slower to commute, and we'll get some smoke. I don't think we will, though. The other one, rotate the board so I don't mess it up. Put some more flux on. I have a big blob. There we go. And double check that I have it the right way around, which I did not. Okay. Oh, that's gonna get annoying. Oh shit. The other one's moving too. There we go. That seemed to be well connected, well enough. All right. Let's do a bit of cleaning while the board gets cooler. I did order a way to make the board cool very quickly, but I haven't received it yet. So hopefully that's good enough. Let's clean up. So here cleaning with IPA is kind of a bit futile because it's going to bubble up, evaporate immediately, but still going to do it a bit. What I should be doing is just try to soak up the flux with no alcohol, just a Q-tip. Let's see how that goes if I try. Let's grab a Q-tip. See if I can actually soak some stuff away. It's nice and hot, so it should come off fairly easily without IPA, and then I can finish with IPA. But yeah, that's about as far as the Q-tip is going to go. So that sponge though is pretty much dead. Let's go for another one. Q-tip my way here. So you can see it kind of cleans it up quite well. We don't really need IPA when the flux is hot. It might be a problem actually. Sometimes you might not want to use IPA because it will cool the board quite quickly, and it might lead to cracks in the solder or something. Not something that I have experience, but something that I am aware of. I'm gonna put some heat here to kind of remove the grime around this one because it's awful. There we go. Sometimes just a bit of heat can greatly help clean stuff up. I mean, there's a limit to how much time I'm willing to spend cleaning up a board. That's going to be crashed in a bundle very soon, but you know, just some professional, well, I'm not a professional, but some amount of effort I don't mind. Just need to be presentable. As soon as it's out of the door, I don't really care. All right, now we have a board and we need to test it. And we'll need to make a ribbon cable, as always. Let me see if I can find one that will work outright. Could use this board. Does Mamba this board doesn't have, it does have the, I'll use my test board actually. This one can go inside the repaired stuff box, which we have plenty of things in at the moment. So yeah, just one more. Gonna need the boys to start breaking stuff. Or maybe I was thinking if people are interested, I might do some kind of giveaway on the stream and try to give a repaired board to someone who needs it. Could be something of interest to you guys. Right. Let me pull the test squad. So hopefully the SpeedyBee FETs did their job. Let's bring my box of ribbon cables out. Let's see, maybe we'll get lucky. Let's grab one that has center channel motors. Because I think my... Okay, so this ground bat and motors. And this is ground bat and motors. Oh, that looks like we got lucky. There's a motor wire that tries to go away. Let me fix that quickly by pushing the tab. Doesn't really matter because it's not even a motor wire, it's like telemetry or something. So let's shove it in and forget about it. So yeah, I think that's good. Ground, oh, VCC and ground are flipped here. I'll need to flip them here. On this side though, ground is on the exterior, so just need to flip VCC and ground. And I think the oh no, it's not good. The motors aren't great. So let's see if we can find a straight one. This might do. This might do. So we have VCC and ground. So ground would be the red here, but probably fine. On this side, ground will be the red too, and the motors are straight. Yeah, that's a good one. We'll use this. Remove this. Let's give this guy a few motors. And we'll also give it, so I need to undo my setup for the, the test setup with to test the FETs. I'm a bit sick, so sorry if you can hear me. Try to not to sniffle too much, but if I cough a bit or sneeze a bit, I'm very sorry. Oh, I removed the alligator clips. Well, where's my alligator clip for this one? Oh, it's here. It is here. It's very quiet in chat. I expect most people might have the stream in the background while doing other things. That's perfect. That's a perfect use of this stream. I'm doing my stuff, repairing and having fun. You are doing your own thing, and you're giving me views. That's good. So yeah, absolutely no problem with that at all. What are your guys repairing or working on your end? Tell me in the chat on voice. I'm interested. I think like a repair stream is probably a great companion to just tinkering on your bench. That's what I tend to do with like longer streams. Just enjoy the companionship of you and do my own thing. Photoshop Illustrator as usual, yeah. That's a good thing to do with a stream on the side. I love tinkering. I have a bunch of bench work to do actually because I'm converted on my Bando quads to brand new motors on MR30 connectors. So yeah, I did most of it yesterday, but it's a lot of very repetitive work, lots of soldering, lots of cutting and stripping wires and thinning stuff. And yeah, it's not that thing is not good. Okay. Those tweezers are better. So yeah, so one of the things I'm kind of worried about is because I could see the sparks when I was testing the gates. Could be that the driver, the chip driver, the FET driver is damaged. And if that's the case, well, we'll need to swap it. I mean, at least we know which one it is. There's only one of the 4 ESCs that seems to be having issues, at least on the FETs directly, so should be an easy swap. If I have a donor, I should have, they're pretty standard. There's like only a few different types used. Okay, so now we don't mess up plus and minus. Black here. That goes over. And hopefully I didn't mess up the wiring. I think that's correct. I'm going to go for a overcurrent protection, which is my way of doing a smoke test. And let's go. Okay, this guy is not beeping at all. And let's see if it connects. So that's the one we repaired. So we'll see what happens when what does it communicate at all? Because it could be the driver is dead. That sounds not very unlikely. So let's see what does it communicate? Motors. Okay, it communicates. So let's see if it spins. I'm expecting it probably won't, but you know. Yeah, it just doesn't. Does do the single motors work? That one works fine. That one works fine. That one works fine, but the one we repaired only has one phase working. That seems like it all does kind of grind. Yeah, so that means there's, I mean, some of it is kind of okay, but what we're gonna do is start swapping parts, start swapping the FET, and is this Blue Jay or BLS or BL32? I think it's BL32. Do you remember, Grimka? No.
BL32.
Yeah,
as
because
far as I remember.
Oh yeah, of course. I mean, I'm stupid. It has bidirectional and did the BL heli sound, so it can't be BLS and it wouldn't be Blue Jay. So yeah, so we can, if it's the MCU, we fucked. But if it's the driver, then we might be good. So we'll try swapping the driver. It's gonna be fun. It's a small IC that's very easy to swap. So if it's a 4-tier IC, actually I only have one in a box, so that will save us some time. It could very well be that the FETs are just not correct, Might be that I soldered them badly, so I might check, I'll do a quick check whether it's all continuous correctly around the FETs, so I can exclude me messing it up. If I did mess it up, I'll fix it and I will test again. But it sounds somewhat likely that something else died. And if that's the case, we hope. If it's the MCU, we can't really fix it until we have the exact same board, because you can't flash BL. I mean, we could fix it by swapping the chip and then flashing AM32. That's something we could do. But if we find the same board with the same firmware, then we can just swap the chip and it's going to have the same pin out. If I found any random BL32 chip, it might not have the same pin layout and it won't work. I can't just transpose it, since I can't really flash it anyway. So I would need to flash AM32 in that case. But it's a bit of a shame to spend some time flashing AM32 when you're not sure if the whole thing works at all or not. So let's go under the scope and do some testing. So the FETs I soldered. Testing the gates is going to be awful on this side. Does it seem well connected? That's not this side. Should be this. Will be this side. And it looks correctly soldered to me. Yeah. So in terms of soldering, doesn't seem too bad. It's going to be this side this time. That's not these ones. This guy. Yeah. Yeah, that's all soldered correctly. So it's probably not a soldering job. So those are R3 chips, and this is the SA something driver, and that's the one we want to swap. I mean, I can try. One of the things you can try for continuity to see if it works, if it's like continuous correctly, you can go to resistance mode and get your probes. Where's my black probe? Where the hell is my black probe? Nah, here. Oh, sorry, I didn't put the microscope on. So yeah, I was checking some stuff, but yeah, so that's the driver chip here that we want to change probably. And I'm going to check that I'm getting continuity between the gate here, resistance mode. Actually, I can go continuity. That's going to be easier because that will give me ohm readings. And this gate should be continuous to one of the pins here. Should be continuous to one of the gate resistors here. Yeah, that's the one. And it should then be continuous to one of the pins. Wait. There it is. Okay. Should be like 10 ohms somewhere. Where is it? Where is it? So this should be 10 ohms. Maybe it isn't. Maybe the resistors. Oh, now I think about. Now I see it. So let's see if we can focus on this. It could be. Now those are kind of cooked. I'm not sure. but it looks like it could be cooked. So that would explain. So let's go zoom a bit, and I'll check those, and then we'll, because we know this one works. So this should read. Let's go for ohms resistance. So yeah, when I touch my probes, I'll get some reading. So we should be getting some amount of reading here. No? Oh, yeah, 10 kilo ohms. 10 kilo ohms. So don't, 10 ohms, that's one of the, it should be about 10 ohms. Why is it 22? Maybe it's 22. Should be one of the gate drivers. 22. There should be 3 of them at 22. Yeah. And now we should have 10K, 10K, I'm guessing. Or 22 as well? No, 10K. Oh, 22. There's 4 at 22. Oh yeah, of course there's going to be 6, right? Because there are 6 FETs, not 3. So the other ones are probably this one. $10 ohms, yeah. And that's a cap, isn't it? Yeah, that's a cap. So I don't know where the last one is. So let's have a look at these then, see if they're busted. Okay, 10K. 10K. 12K, 8. Yeah, that doesn't sound normal. We'll see where it goes. And they seem to have like a blow. 2K is not something that seems normal. 22 ohm, that's good. 22. 10K, yeah. Does this one look busted to you as well? It's 10K, so it's probably fine. Oh, is it? It does look busted. No, it's just dirt. Is that just dirt on those? Yeah, those doesn't look like just dirt. We'll see. Yeah, but that's the S3, S4. No, this one we don't show. So yeah, let's check this one again. Yeah, 8K. It doesn't sound. And yeah, those look like bad values. So let's see where they go. Let's go to diode to continuity check, and we'll try to find. So those, this should lead here. No, yeah, this should lead here. This here, and this doesn't. So these 3 should be 3 gates. So let's see if we can find the gates they match to. Yeah, so this one's this one. And I'm guessing this one is going to be the other one we changed. Yeah. So those 2 are busted from the transistors we busted. This one, I'm guessing, is going to go to that one all over here. But this one's good, and it's not one of the busted. Yeah, 22 ohms. So those 2 resistors are dead, and they need to be changed to 22 ohms. Yeah, 22 ohms. These ones, they should be 22 ohms, but it's, yeah, half a K, and this is, yeah, 1K. So now you're asking me, Where can I find, when I can be sure to find the right resistors? Oh, that'd be nice if someone had bought a sample of all the resistors and all the size of them at all sizes, like this thing that has many, many different values. Well, that's going to be very convenient. So now, the hard part is going to be to remove them and put the other ones back, because it's small stuff. I think it's not 0201 though, it's 0402, which should be nice. So I'm going to go digging for 0402 resistors in my, so I have all those samples, and I just have like 25 of each kind of size. So yeah, we'll look for 402 resistors. They are obviously at the very bottom of my drawer. I've tried everything and I haven't found them. There we go. 1K to 10M. Literally the last bag in the drawer, as always. So this should contain, if we look at this, we have a list. Let's zoom in. We have a list of what it contains. It has some 22R. That's what we want. So we'll want those. And let's check that it's the right size. Let's pull out of the bag, go to the microscope, and does that look like the right size? Yeah, it looks like it's the right size. Or is it bigger? Let's find one of the ones we want. So it's all written on them, thankfully. 27, 24, 22R. So that's my 22R. Let's grab some fine tweezers. Lift the reel. So those reels are meant for pick and place machines. That's why it's like kind of they're all aligned, and the machine will unroll the piece of like ribbon. There we go. So is it the right size? No. Is it? No, I think we need smaller. Let's see what the 0201 look like. I thought it was 0402, but maybe it's 0201. Let's pull out the 0201. Give me a second, please. One capacitor, 402. I'm still kind of a noob when it comes to component sizes. I'm not very good at seeing what they look like. So let's see. Does this look better? Yep. Unfortunately, yes. So it's 0201 then. Oh well. We'll do them. We'll find a way to do them. What I'm going to do probably is put a bit of aluminum tape around the plug to kind of try to redirect the heat away from the plug, so we try to not melt it. So I have here some aluminum tape, as one would say, in around these parts. I'll try to not glue it too close, but no, not very good. Let's do it again. Let's do it again with another piece of tape that I try to pull straight. Struggling with the tape. It's quite thin stuff. Should do the job though. what I'm going to do is stick it on top and then go and fold it. And then go and fold it behind, so we can kind of protect it that way. Yeah, that should possibly help. All right, so we're looking at those two center ones. Let's remove them. Good thing is I have 25 of the good resistors, so I can try again. Let's try. I really want to go from the left with my tweezers, but if I do that, I run the risk of really smoking this. We'll try it anyway. Flux. We'll go for fairly low airflow. So like we'll go for 40% and high heat. Still on high heat. Try to get in, get out quick. Oh, my board isn't clamped correctly. Let's remedy this. That's the one. And that's the two. Right. Let's actually come with an iron and make some nice leaded solder blobs on this, so it makes stuff easier for me down the line. So we'll need some more flux. We'll clean up the flux. Let's clean up the flux first, then put some more flux. Put on some more flux. Then come with the iron and solder. Try not to mess stuff up too much. We're doing some quite small stuff today. Between the trace repair we did on the USB and this, we're doing tiny stuff. Hey and co, so we are repairing a, hey Bash, we're repairing an ESC. So we found two FETs that were shorted, two FETs that were not working, like I tried opening them up with like injecting voltage on the gate and they weren't up, so I swapped those and the motor's still not working correctly, and we started looking at the driver chip, which is the SA chip in the middle, and I noticed the two small resistors on the side seem to be busted. So I make sure I check the resistance on them, and they were indeed reading bad values, and they were the ones that match the two FETs that were destroyed. So it makes sense. So now I'm going to replace those two resistors, test again. If it doesn't work, I'll replace the driver chip, and we should be good, hopefully. But in case you don't know the size I'm working out, I'm going to show you this. This is the resistors I'm going to be putting on. So yeah, you can see this is about the size, smaller than a grain of, about the size of a grain of salt. So I'm going to be putting one of those on the board, two of those on the board. Hey, NeoFlows, you got some FCs and ESCs you happily donate. I'll be absolutely delighted if you were to send them for the stream. However, I have to remind you that I'm in Europe and it might not be cost effective to you to send them at all if you're in the US. However, if you really want to send them or you're in Europe, you just hit me up on Discord and I'll give you my address and you can send them. That would be very much appreciated. As long as you're aware of my the way I function, I don't really do repair for people. I just put them in the box, and then people, when I see me in real life, can grab stuff from the box. Oh, you're in the UK. Well, if you're happy to send them, I'd love that very much. So those are the 22 ohm ones. So now the goal is to find a way to remove this without them flying across the room. And that's easier said than done. Okay, looks like it's coming off okay. Now I need to grab it and what I could do is drop it on the board. Man, that's gonna be fun, isn't it? Thankfully, I have 25 of them because I'm gonna lose one of them. Okay, right, we have one. Now I just need to lay it flat. Try to grab another pair of tweezers. Yeah, those are 0201 size components. They're not the smallest that exist, but they are not the biggest. I can tell you. So now we'll be trying to grab this. I'm making my probes beep, my multimeter. Grab this, try to not shake to death and solder it back on with hot air. Hot air isn't the only way I could solder them back on. Could do it with a multimeter, but at that size, it's getting quite hard. Oh, I squeezed my tweezers too hard and I kind of, like, did I manage to, yeah, I tacked it, so that's good. I'm gonna now put some more flux on and kind of reflow it gently so it floats. So now I'm just waiting for it to move and tell me it's in place. I shouldn't have to touch it. I think we're there. It might be there. I think I saw it move. We'll call it good for now. We'll test continuity later with the pad. Let me now grab a second one and do it all over again. That went well. That went surprisingly well. So I'm happy. Now we need to find a... So now that I've started this, should be easy to peel to the next one. Oof. Oh yeah. Oh yeah, it flew away. That flew away. Okay, so either we find it, which I very much doubt we can. Oh, I'll grab the next one. I just don't want it to short stuff. Is it this? I found this. Nope, that's not. I just found a black thing on my mat. Okay, I'll grab another one then. I just blowing on the board to kind of remove any rogue resistor. I'll try to not fly. Okay, this one I know where it went, so that's good. Fun times. Fun times. Right. Let's see if we can get lucky twice. Put some more flux in on. I knew having those kits with all the resistors and everything would come in handy. I mean, I'm not sure we're going to fix it. Is that going to be enough? I don't know. Is it going to be... will we need to swap the driver? Will swapping the driver help? I don't know. But at least it's a good way to try. I'm having fun learning things. And... oh, it pinged off. So that's the issue with those tweezers. If I squeeze too hard, the two tips kind of cross each other and I lose the component and it pings off. So let's see if I can try other tweezers that might not do this. And we'll try my flat tweezers, the one I use for reworking with, so those ones that I use for working with tiny wire. We'll see if those are better. And we'll try again. And I need to be able to also kind of anchor myself somewhere. And I have the hot air kind of blowing around, and it makes stuff very hard. So yeah, that's why I have 25 of those. And if I run out of 22R, I can just buy specifically 22R resistors. Yep. Got one. Let's try again and try to not burn myself doing so. So let's see if this... and I think we're just good, plain good. It just went on. I saw both sides melt. Thanks to the leaded, it went well. All right, let's use the multimeter and check. I'll give it a bit of cleanup because why not? And then, well, I'm going through the sponges. That's right speed, but they are very good. Man, that'd be awesome if that was all that was needed, but I would be very surprised if I didn't need to change the driver. But we'll see. We'll see. Okay, so before I remove the tape, I'm going to use the multimeter. And I'm in continuity mode, but I should be able to test. So here, I should have continuity between this and this, with the resistor and the pad. And this too, 22 ohms, 22 ohms. Okay, so that part is fixed, and we still have 22 here, I'm guessing. Yep, okay. So now we test. We'll see if the port is blown. Let's zoom out to give you a sense of size. Yeah, port's good. Right. I can tidy up my resistors. So I managed to only lose 2, which is, I guess, a good score for me. Let me have a quick look under the microscope, actually, if we have a rogue resistor somewhere that pinged to somewhere where it could short. I would not expect we do. Yeah, so they are lost forever. You're never finding an O201 component in the world, unless you're extremely lucky. Hi, shucks. I have another, actually that reminds me, I have another ESC that did a similar behavior. So it might be the same problem. It was Shucks disease ESC. So might have to check the gate resistors. Could be that. Oh, just poked myself on the tweezers. Why is my tip not connecting correctly? There we go. Okay. Let's do this quick. We only need to do this one actually. So let's only do this one. If it spins all right, I'll do the other one to check if it spins the right speed. But if it doesn't spin all right, there's no reason to bother doing the other motor wires for the other FETs. And that would be motor 4. All right. Let's see what we get. I mean, it couldn't have worked before anyway with those gate resistors busted. So now the question is whether those got busted because something bad happened in the driver is the other question. Let's go. No lights on the thing. That's not necessarily an issue, but it doesn't usually ring good bells. Or whatever the expression is. It's not a good omen. Because usually one of the phase at least is active and it just starts doing the thing. So we might need to be swapping the driver 2, which hopefully is the only thing left to do. But let's see. Spinning up the motor. No. Look at that. Look at that. It's spinning. Now, is it spinning good? Nope. It's not spinning good, but it's spinning, so progress. Yeah. Yeah, the sounds you can't hear, or you might be able to hear, like the that's my my PSU going mad, switching from current limit to voltage limit. So it means that's drawing way too much, too many amps. And what we'll do is we'll do a quick thermal cam check, but we'll probably be seeing something getting quite hot. Let's unplug this, plug it back on somewhere. It doesn't hurt, and we'll use the thermal cam. But I'm guessing we're going to see something get quite hot, and so we'll swap the driver. That's fine. It's easy to do, much easier than what we just did with the resistors, so I don't mind. Yeah, Chuck, I forgot. I started too early because I forgot my Tuesday stream are supposed to start at 10, so I'm streaming for 3 hours. So here, let's connect. We'll be looking at what's happening here. I mean, it could still be that the FETs we put on are just a bad idea, putting FETs that don't match. That's very well might be an issue, but I don't think it will. Oh, there you go. There's one FET going super hot as soon as we push, and just one of them. So that makes me think, Yeah, it goes super hot. Could be that was one of the SpeedyBee ones that's a bad one. So we'll swap the driver. If it still happens, we'll swap the FET, because it could be that my donor was a bad one. Can happen. It is a donor. Yeah, it's not something the drone is doing. Is my PSU going at the limit of its amp draw. But the good thing is the other FET we swapped, the other SpeedyBee isn't heating up, so that makes me think having a different FET is not a problem, which I'm not surprised by, but it's nice to confirm. But yeah, so what I'm going to do first is do another check we did before for FET continuity. Because that's actually probably the first thing I want to do is make sure the FETs I put on work. So I'm going to do that. That's going to be the first thing I do on this board. We'll get done. We'll get to solve that problem. We'll get all the way to the solution. All right. So we'll need to set up the contraption for testing. So I need to bring my cable back. This goes here. I want to do 5 volts, 100 milliamps. This clamps on my probe, and this goes to continuity. We're good. 5 volts, and I want my sharp implement for the 5 volts. There we go. We are ready. Let's go back to the microscope. And first of all, so those, if I remember correctly, are the ones that are tied to the pads. So this is the defective one, so we might be able to see something here. So if we check, this should be continuous, it is. This should not be continuous, and that should open when I inject 5 volts here. And it doesn't, so that FET might be bad. That might explain the issue. Or maybe, my PSU wasn't turned on, so I wasn't injecting anything. Let's try again. I would expect this to be good because it was heating up. It is, yeah, so that would have been surprising. So let's try the other two, but I'm expecting them to be good. We'll see, because it does spin correctly. Good. And this guy. Good. Now let's test the other ones on the other side. So I need to clamp on the minus here. And there's the 2 here. And we'll need to probe, so that should beep. Yeah. Probe here, turn it on here. Okay, the FET looks good, so it's probably the driver then. See if the FET is good. That's probe here. That should beep. Yeah, let's probe here and turn it on. Yep, so it must be the driver. I'm pretty sure I have those drivers, so let's swap that, and hopefully that's all we need. And if it's not that, then it has to be the MCU, and we can't swap those because, I mean, we need to swap to AM32 to swap those. So, driver. Let's find a donor. I know I've seen those before, so it shouldn't be too hard to find. Nope. Yes. SA62, SA62, 88. Yeah, good. SpeedyBee has the beans. And I'll start with removing from the donor so I can do a swap afterwards. Can remove and put the new one on. Let's grab this boy. Do I have any reason to trust any of them more than others? No, not really. So let's grab this one. We'll go a bunch of airflow, like 60–70%, still tons of heat. And that should come fairly quick because it's a daughter board on top and it shouldn't have that much, as much thermal mass as the rest of the ESC, hopefully. Indeed. Indeed. So we need to make sure we use the correct pin 1. So we respect the board orientation, the orientation of the chip. So here, there we go. Let's make sure we have pin 1 here, so bottom right. So we need to I'll position my other chip the right way, so 180. So when I grab it, I can drop it on top, and that should be pin 1, yeah. Yeah, okay, let's do this. So I'll remove the defective one, put some flux on, and then put the new one on. Let's throw that away very far, so don't put it back on. Come with some flux. And well, I'm gonna reflow the other one gently. I'm gonna go for like 30% airflow. I'll put the new one on. I'll drop it in, and then I'll just let the hot air do its job. Pull it into place. We should see it kind of float into place to some extent. And stuff melts. Not molten yet. Starting to melt. There we go, almost there. I can see those ones still need to. There we go, we are positioned correctly. Yep. All good, I think. Looking good. Looking good. Looking good. Looking good. All right. Let's try this again. Let's see if it helps. If it doesn't, then I'm probably gonna have to give up, though I might try switching the two hot FETs for new ones. But that would be my last ditch kind of pointless effort to save it. What? I would say I have a 50% hope that it's fixed. 50% chances. Yeah, it looks pretty well sorted. Quite happy with that. So yeah, I'll blow on it and. Hey, Baloo! It's going well. We're swapping a bunch of things. McShaky FPV, you missed fun things. So basically, we found out after we got it spinning kind of, but also going super bad, spinning super bad, and we actually had to swap two of those tiny 0201 resistors. They were busted. We found they were busted and swapped them from my stash of resistors And yeah, and now we're still getting, it's better, it's pinning now, but it's going bad. So we just swapped the driver, and hopefully the driver fixes it. If it doesn't, we've seen that a FET was going super hot, so it might be a bad driver, but it might be the FET that I put back on is not very good, but we just tested it and it opens up correctly. So kind of thinking that if it doesn't work here, it's going to be probably one that I won't be able to fix. I'm blowing on the ESC to cool it off. All right. I mean, it's, yeah, like I said, if I wanted to save it, at that point I would have to swap the MCU and flash AM32 because it's a BL32, so not much I can do to reflash the correct target. I have to say though, I'm super happy we managed to get those 0201 so well. I'm still not very not confident with 0201 components. They are tiny as fuck, and yeah, one day I'll manage to do it without losing two of them, but that's a good start already. All right. No careless whiskers, no, we're good. Let's plug it in. Oh, I forgot to turn off the PSU, and because I was giving it 5 volts, it was spazzing out. All right. Let's see how it goes. Still no light here. She's not necessarily an issue, but that's my confidence is getting lower and lower all the time. Let's spin it like we mean it. Nah, that doesn't sound good. Yep. It doesn't sound good, and it does. Oh! No, wait. What's my current limit? Yeah, it's 5 amps. So yeah. There's definitely a phase that doesn't work well. I'll check with the thermal cam that it's the same thing that doesn't work. And we'll swap the FET one last time, the 2 FETs, since we are nearing the end of the stream, so there's not much else I can do, and if it doesn't help, we'll have to call it. So we are looking at these 2 boys. Yep. Same thing. One of the likely things that got damaged is the analog circuitry that reached the 0 crossings on the MCU. And if that's the case, we only can swap the MCU. So there's no other fix. So yeah, we'll swap the FETs, this one and the one on the other side, and give it one last go. Could be that we had bad FETs, but I don't believe we do, because they seem to be working fine. Oop. Let's grab another SpeedyBee. We'll go back to maximum airflow, pull those right off. Let's go in and out quick. I'll prepare a FET on the side. Should be fairly quick because we did put some leaded. So it will melt faster. There we go. And then we want to come in with some flux. Put the FET the right way around. Oh, the tweezers. I'm getting shaky towards the end of the stream apparently. Okay. How did you bang on? I might move it. Getting shaky. Not even like we don't really need to be that accurate too for FETs. They just need to be like to have the pads correctly done. Gates need to be on gate. There we go. We have a small ball which doesn't matter at all because it's all continuous anyway. Let's do the other guy on the other side. I need to use the more appropriate tweezers actually. It's going to be easier. Yep. Get a new one from the donors. And it's going to go that way. Flux. Once you know how to do it, it's actually super quick to do. And just tuck it into place, and then come back, move it, and it's all molted. Press on it, and should be good. Right. That's our last chance. That's our last chance for it to be fixed, but I'm not very hopeful. I truly believe the MCU is dead. Well, the analog portion of the MCU is dead. And yeah, I mean, maybe that means we need to swap the MCU and flash AM32. Maybe that's something we could do on stream for people. People might be interested to see that. I need to see if there's a target for this board, and we could do that. That would be an interesting thing to show. I've done it only once, so I'm no expert by any means of flashing AM32, but it wasn't that hard. Though it does require you installing weird software on your PC that you need to create accounts for and a bunch of things. It's a bit. It's not that the fun part, but. I'm currently blowing on my ESC. Not to toot my own ESC, but I might not have fixed it, so I have nothing to toot. Oh, it's hot still. It's hot still. Okay. Let's confirm that it's not the FETs. What are the odds we get bad FETs twice? I mean, could have been my soldering job too, but it really did look clean, and I haven't had many issues with soldering FETs if I take my time to do it cleanly, so I have my doubts. All right. It's last chance. Let's try. Let's go. Ah, at least we get lights here this time, but it's a bit random. It depends on the position of the motor. So, but when you get none, it's like 1 in 3 chances or 1 in 6 chances, depends. Let's see what it does, how it does. And motor 4. Still doesn't sound great. It does go grr. Yep. Yep. Still doing the same thing, so it's the MCU. Oh well, we did interesting things to that ESC today. We didn't get to fix it, but we did get to replace the USB port. So we have 1 win today, and that's good. Always want at least 1 win. So I'll keep this one, and maybe I'll use it to swap the MCU. I have plenty of donors for this MCU, and if I can find an MCU, what I can try is swap the MCU and hope the pinout is correct. So it's going to be pre-flash with AM32, and if I put one with not AM32, BL32, it might just work. There is one chance. If I could find a donor Mamba, that would be perfect. But if I can't do that, I'll try flashing AM32, and that's going to be that could be fun on stream. So, and then maybe we can save it that way. Could be that something else is bad. I would actually. Now that I think about it, there's probably 2 other resistors on the other side that are blown. So I'll check that. I'll do a quick check, and if it's the case, I'll keep it for next week. Let's now that I'm thinking about it, let's check, and before we end the stream. So the resistors on there, so they're going to be here. So of the ones we swapped, were here, and the other ones are probably going to be here. Though the ones we swapped are probably the ones. Let's check if they're still alive, by the way. Could be that they're burnt again, if the things was burnt. Let's do one last bit of diagnostic. So the ones we changed were these guys. We're still reading 22 ohms. And here, ohms, and here, 22 ohms. Now we need to find, so this, I think, should be 10K. Oh, this one had a sheet value too, I think. Maybe there's another one we need to swap, but all hope is not lost yet. I'll go for, no, not diode mode, resistance mode, because this one was 10K, and this one was, no, it was 10K, so it's good. So we need to find the other ones to the other gates on the other side of the board, and they could be these ones. Let's see if we can get some Let's try on the good one. If we see some 10 ohms somewhere. It should be, I would expect those, yeah. No? Okay, 4K. I would expect some of them to be the 22 ohms used for the gate drivers on the other side. 10K. 1K. 1K. Where are the other three? That's the question. 10K. 4K. 20 ohms. There's one here. Whoa, no, 10K. So there's this one here is a 22 ohm. Let's see if we have the... Where's the matching one here? I don't know. Here? Not necessarily. I don't know what this one here, where's the matching one is here. I don't know. I do not know. It's hard to say. Oh, actually, I think they're linked here. That might be here, actually, the other 20. No, but that's the trace that goes to the motor command, so that's not it. Yeah, I don't know where they are. There should be 6 total. What I can do is try to locate. Oh, I can't check on the other side the gate drivers. So yeah, I don't know where the gate drivers are. What I would need to do is look up the data sheet for this chip, so I can see which pins correspond to the other 3 gate drivers, and I can try to track down the resistance. I'm not going to do that here though. I think we're gonna stop it here. I'm relatively happy of the work we did. Sorry we couldn't fix this one, but good investigation, good things we did along the way. We did fix a few things, and it does spin now, badly, but it does spin. So yeah, I'm not giving up on this one. Might keep investigating a bit off stream to see if I find something wrong, and then I'll bring it back to the stream next week maybe to try to fix it. And we'll try some MCU stuff. It's not that this is a very precious ESC that needs to be saved. As always, I'll repeat it, but I'm not trying to get... like, if I was trying to do this as a business, I would have ditched that ESC as soon as swapping the FETs didn't work and call it done and move on to something else. Here, the whole idea is try to figure out what's broken, figure out the puzzle, basically. So, hey, son, you arrive in the conclusion. But yeah, so I want to understand better what could cause those grindy basically the FETs to overheat. If I could get my hand on a Mamba donor, that would be awesome, because that means I can put the right FETs on, so we can exclude the SpeedyBee FETs from being an issue, though I don't think they are. And yeah, that's all I have for today. Thank you very much for coming to the stream. If I can grab 5 seconds of your attention, if you're still around, that would be super nice if you could click the like button on the stream, and if you can write me a very small comment under the video, even if it's a smiley or whatever. It's really nice for the algorithm, and I get more views that way, so I can keep doing streams for you all. All right, that's going to be it. I will wish you a very good end of your evening or afternoon for guys in the US, and I will see you next time. Goodbye.